Okay, we're going to start with the third presentation, which is by Dr. Wouter Dullaert from Toyota Europe. He's going to talk about how he plumbs differently. I didn't know he was a plumber, but he's got a number of degrees, and now he's just a plumber. It's a bit disappointing, but I've been trying to get Toyota Europe to do a presentation for my Data Management Association for a long time. Yves Tassenois is, I guess, Walter's manager, but he's fighting some CRM wars down in Rome and eating pizza and drinking Chianti probably. But Walter is doing a lot of work in the customer data unification space on the international levels at Toyota Europe, so he's going to talk about that. Okay, so go ahead, Walter.
Hi, so I'm Wouter Dullaert. I'm not sure if I should give some background myself. I've got a PhD in electrical engineering. I used to model Maxwell's equations in a previous life. And for a few years now, I'm working at Toyota Motor Europe in the IT side. Our IT is structured like our business, so we have corresponding departments. So I sort of work in sales and marketing. And there I'm responsible for a few projects and some more of the technical bits. I'm going to talk about the customer data unification that we're doing. And it's really, in my head, it's kind of around plumbing. In and of itself, it's not really very useful, but you need to do it to enable a lot of very fun use cases. This is a short overview of what I'm going to do. So number one is, why do we actually need to do the plumbing? How do we get in that situation? And why do we want to get out of it? The next bit is, well, traditionally you would solve my problem with what I'm going to call data integration, you know, the thing that has three big steps called E, T, and L. And then the last bit is going to say why we're doing it different and what that brings us and what the key outcomes are that we want to see. So yeah, how did we get in? How do we get here actually? Well, Toyota in Europe grew kind of organically. Like initially, there was just one retailer in TGB, and that is exactly this year, 50 years ago, as they told me yesterday. So after a while, you know, we sold a few cars, so we got a few more retailers. You know, a bit spread out across Europe, and then you know we thought, you know, just shipping all these cars to all of these retailers, maybe not so practical. We can do better than that. So we got a national distributor in the UK. So we had a few retailers across Europe and one national distributor in the UK that was trying to group the existing retailers. So as time went along, you know, we got a few more. We got lots more retailers and more national distributors. But then the guys in Japan thought, well, you know, all of these European countries are so tiny, we can't really see them on the map, and we're talking with all of them separately. Maybe we should put something on top of that. So they created Toyota Motor Europe, which is the thing I work for. And they try to centralize their operations through us. So they drew this big box across all of the distributors and retailers and called us Toyota Motor Europe. And so the present situation is that we have, you know, a lot of distributors, or in Toyota speak, NMSCs for national marketing and sales companies. And the big ones we actually own, so they're a fully owned daughter company of Toyota Motor Europe, but actually a lot of the smaller ones like Toyota Belgium, they're sort of franchised. So they have the right to sell Toyota in Belgium, but they're not owned by us. And then actually the retailer network sort of looks the same. Some of these distributors, they own the retailer network, but others, you know, they just have a few big franchises that they need to work with. And what this actually boils down to is that, well, there's this thing called Conway's Law, I think it is, and that says that your IT systems kind of look like your organizational structure. So all of these dots, you know, they all have customer data because they all interact with the customer in one way or another. So if we go through that, so the nice thing about it is that all of the customer data lives close to the customer. Because the most important thing when you're selling cars is that personal interaction. You know, if you like the sales guy and you like the support at this guy, you'll go back and you'll buy a new car. So, in fact, that's why we first had retailerships. So it's actually a good thing that it lives all there. But so, you know, because the retailer, he'll have the sales and he'll do the repairs and he'll have data on you to manage those things. And then the distributor, you know, they take a step back, but they also have a bit of customer data. So typically they'll get the national car registration data, which could be helpful for CRM purposes, or they'll do some national social listening. They manage a few other things as well. But increasingly, relevant data around the customer and what he's doing and what you would want to exploit in CRM activities is actually coming in through us. It's coming in centrally at Toyota Europe. So we actually have the platform on which all of the websites for all of the distributors across Europe run. So that's actually managed by Europe. And so we get the click stream of that. But we also get leads. So if you request a test drive, that actually first arrives on a server managed by us and then goes to the distributor and the retailer. We have a central warranty system. We have all of the car telemetry. Now, that is going to be big in the future. Right now, we have all of 10 cars on the road that send data to the mothership. So, working on it. So the question now is, how do we link all of that together? You know, so how do we feed this back? How do we actually which retailer should we contact? Actually, so somebody requests a test drive. Which retailer should I go to? Which one lives close to you? Obviously, the customer, he will add it in, but still, how do we link it all together? How can we give an overview of what the customer is doing in Toyota land? And so, to give you an idea of the scale of the problem, we went out and start counting the databases that have customer data. And so on the TME level and the retailer level, if we sum those together, we end up with roughly 270 different databases that have customer data in them. And that's before we actually get to the mess that is the retailer network. So what it boils down to is that if you do this the traditional way, as Ted said, if you do it with the Excel and you start mapping the columns, you know, you're gonna hit some bumps. It's not gonna work. And to drive that point home, I have a few slides on why it's not going to work. So, as I mentioned, like data integration typically consists of 3 phases called ETNL. So I've named them slightly different here, but so we have extract, you do some transform, and you load it somewhere else. So for your extract and transform, you know, let's say you have 2 databases. First step is you need to map the headers. So that sort of looks like this. I've got one source, I've got another source. So this has 3 attributes, so let's copy them over in the output. This also has 3 attributes, but when you start looking at it, you know, this one, it's actually 2 attributes, and for some stupid reason, the developer decided to concatenate it in the database because on DB2, you know, these things happen. So you need to put this T box in the middle to split it out into different attributes. So all right, cool, we've mapped everything. Next up, you need to link the actual rows, the actual records that you have. Now, if you have a joining key between these 2, that will be relatively simple. But if, you know, these are 2 databases from competing retailers, there is not a joining key. So you write yourself some business rules. You say, you know, if the name is the same and the address is the same or the telephone number is the same, it's the same guy. If the name's the same, what was this? Telephone number. And, you know, the gender's not the same, they're definitely distinct. Or, you know, you have a few of these rules for 2 sources. You can probably get your head around it. You'll end up with 4 or 5. It'll work well. You eyeball the result set. Everybody's happy. So this works. So your boss comes along, hey, that was a success. Can we also integrate the data from source number 3? So you say, sure. It starts to look a bit more, you know, it's a bit more spaghetti in the middle. You have to shuffle. the data around a bit, but you know, eventually you again end up with nice records, and then you go to your rules and you say, well, maybe I should adapt this rule a bit. I should add a term there. This doesn't work when I add in source 3, and you add 5 more rules that all interact, and we end up with a nicely consolidated data set. We're good. It's again, awesome success. So after some more time and some more sources, you know, those rules, they start to look like this. And, you know, everybody gets a headache. It doesn't work. You start to feel like this guy. And so you basically say, stop, don't touch it. You put a glass box on top of it. We're not doing anything more. This is it. So yeah, you can get it. What I want to say is you can get, you know, some distance, but when you have 4, 5, 6 sources, it starts to break down. Actually, complexity adds on. Your rules become much more and more complex as you have more systems. The mapping becomes more difficult. Things start to break down. So it doesn't really scale. So the second bit now is, well, okay, we've consolidated everything. So we want to consume this data. So let's say that I have 3 different records, and I said I've identified that they're the same thing. They're about the same entity, the same person. So I've got 3 of those. I've got Bob Smythe, Robert Smythe, and Bob Smith. They're all the same guy. So his legal name is actually Robert Smythe. He calls himself Bob Smythe, and this was a typo that some dude made somewhere. So, but algorithm, when you look at it from the computer's angle, which one of those do I take? You know, which one do I retain in my output? And then actually once you do that, probably you want to know where it came from, but you've made this hard copy, you know, because you do ET and L, so you've imprinted it in a new database, and you kind of lose all the pointers to the old thing. So where did that actually come from? I now have a new record, Robert Smith, but I don't know anymore how it links back. And then, oh, I've got a typo in my slides. So then actually also have, what if multiple consumers have different requirements for this thing? So you're into the modern thing. You've got a web portal where your customers can register themselves. And so basically you want to feed that to this system because you want to that's nice information. The customer gave it to you. So you want to consolidate this, but you don't want to make a new data silo, so you want your portal to use that output. But now you actually risk showing the customer data, a different name than the one he entered. So basically what that means is that the portal always wants to see the data that it supplied. But the sales system, they might want to see the name that was on the contract that you signed. You might have different requirements on how you want to merge these records depending on who's asking to see it. Now, for a big, you won't have too many of those. Most of the stuff that works with CRM, they'll have the same set of requirements on how you want to merge these. But once you want to use it in different of your silos, you'll end up with slightly different requirements on how to merge these things. So how do you handle that? Then how do you handle updates in the source systems? So in one of these source systems, actually my name gets updated to Robert. How do I propagate that through? Well, this is relatively easy. You basically run the entire mill again, but you need to be aware of it. It becomes more tricky when you decide what if one of these consuming systems, gets a new feature and it actually starts consuming, or it starts getting data from your customer. So you can make him a new source. So what happens when somebody actually knows that I'm reading Robert Smith, but I know it's Smythe? How do I tell this to you? How do I get that in my pipeline when he's consuming the consolidated set? So there's lots of things to think about. We're probably, most of us engineers, we know some plumbing and some duct tape. We can solve some of these, but how do we solve them all in an elegant way? It's not always so easy. So what this boils down to, and you'll have seen some of these quotes in a previous presentation, is that traditional data integration is slow. You write a ton of scripts. They're only understood by Mike in the basement, who left 2 years ago. See? Everybody knows Mike, right? So it's very manual, because you need to manually profile all this stuff, clean it, you need to eyeball the data. It's not really fun. Nobody likes to do it. That's one of those scripts when I did. It's costly. It only scales with people. If you want to do more sources, you basically have to throw more engineers at it. And also, very often you'll see that this gets outsourced. You know, once you start at it, you'll be like, I really don't want to do that. I'll get somebody else. You hire some consultants or some marketing agency to go and clean up your mess. You know, you basically put it in a nice box and throw it over the fence. But what that means is that, especially when you're working with customer data, is that, well, you're actually giving your treasure away. You don't know your customers anymore. In fact, this agency that's doing this for you, they own you. It's also very opaque. You'll hardly ever find any documentation. I know there's none for the script I showed you. There's also no audit trail. Why was this merged? What actually happened? What was the provenance of the data? Why did this why did this guy get an email or an invite for some customer event saying, "Dear Mr. No Name"? You don't really know. It's hard to debug. The last bit is it's inefficient. You know, even after we've done all of this, the results, they're not very good. It's low quality. We know this, but it's the best we can do, right? So it's also very hard to keep up to date. So typically we do these ETLs one time. You build that script one time. You squish it, you know, through the the meat machine, the mincer. And out something goes, and you put that somewhere else, and you do this once. Sometimes you'll run this daily or monthly. You run it through the mincer. But you definitely don't touch the scripts. You know, you've done them once, and you're like, fuck, I don't want to touch this. But your inputs, they evolve. Actually, the profile on your input data, it evolves. So some of these rules you might have had, and which worked really nicely in the beginning, 2 years or 3 years down the line, as your systems evolve, they're really not valid anymore. So, what's the new thing then? What are we trying to do? So I've called it Data Unification this morning. I thought it sounded nice. It actually consists of two flows. So we have the forward flow, as I call it, which takes data from your existing applications, your existing, in my case, customer sources, and puts them through the mincer. Basically, that's the forward flow. Then we have the feedback flow, where, well, one of the things that we want to do is we want to stop making customer databases. We've been doing it a long time, but it's time to end. So we actually want new systems to be able to use this consolidated set. But eventually we'll have a new system that has data that it wants to give back and input in this consolidated set. But we don't want to lose all of the nice things that we're doing in the forward flow. So actually trying to get data back in from the consolidated set was quite a tricky problem to solve, which is why I highlighted it separately. So what does that forward flow look like? Well, it starts with the same thing, ingest your data. Actually, that kind of remains the same. You still need to go and fetch it from all your source systems. But we've taken the Hadoop style of approach. So we're basically saying, well, for as much as it's possible, just give it in the shape that you have it. Give it in your schema, and we'll process it when we actually try to unify the data. Because, well, in my case, because I have so many different databases and so many stakeholders, any bit of effort that they need to do additionally to be able to give me data is effort too much. So it should be, to get my hands on it, I want that barrier to be as low as possible. So I want to remove all the friction on sharing your data. Because traditionally, at least with us, like the system that receives the data can specify which shape it is in. And then you go up to the system that needs to give it. So you need to talk to these developers. And you say, yeah, I want it in this shape. And they're thinking, yeah, that's about 2 weeks of work for me. But I don't get any value for it. Why should I do this? But if you go up there and you say, well, if you can just give me a flat dump of what you have a higher chance that they'll say yes. So that's what this is. The next bit is, well, you have to map the data. You still have to do this. So you have to map the fields from your source system into your target schema. And that will probably still look relatively the same. I think I forgot one slide actually somewhere that I didn't put in. So basically I've got one slide that I'm not showing, which shows the different stages we have. So we have the extract stage, we have a mapping stage, we have the link your record stage, and we have the consumption stage. And so the mapping stage and the linking stage, that's where we're using Tamr. So because we want to use the machine learning algorithms that this tool offers us to make the mapping and the linking, which are the hard part of the mincing machine, to make those easier. So that's the slide I forgot, and it's quite essential that you notice. So the consumption part, that one is actually something we're building on our own at the moment. So for the mapping of the data, so initially you kind of still have to do some mapping. Like the first two sources you need to map. You need to do them yourself. You might even need to do a bit of transform, which the Tamr product does support. So for example, to get the shape of the date field similar across all of your sources, that's something you might want to do. But the nice thing about Tamr is it has machine learning. You know, it's machine learning assistant. So they have this nice little robot that's watching what you do. And so when you're mapping this first source, actually in the background, it's profiling all of the source columns that you have, and it's looking at how you're mapping them. And for the next source, it will offer you recommendations. That's here. So what goes here is, well, so I've actually mapped this one here myself, but I've got a new source, and I can now ask Tamr, well, give me some recommendations on which fields are here. And so it'll run a profile of all the attributes that you have in your sources. And it'll come up with, well, the distribution of this looks very similar to something I already know in my target schema. So, you know, it's looking very red. So I suppose that you make it the red attribute. And it's looking very green. So I propose that you make this the green attribute. Now for your third source, these recommendations will be quite okay, but not perfect. But once you get to the 5th or the 8th or the 20th source, you know, he's going to be spot on, because all of these sources, remember, they contain the same entities. They're all about customers in my case. You know, it's not, you know, we think it sometimes, but the customer is pretty much the same everywhere. It's not like it looks like a squid in Spain and, you know, an eagle in Norway. No, it's still a person. It's got a name, an address, phone number. So like the variation on your attributes is not that terribly big. So once you've given it a few sources, it's actually very good at telling you what it should be in the output. And so to the point where at some point you can just, you know, copy over the recommendations because you know they'll be right. So this mapping stage, the effort goes down as you add more sources. Now I'm not sure if you remember my previous slides. Actually, the effort goes up when you do it traditionally. So we actually reverse this. As I'm integrating more, it's becoming easier. So from you know, only scaling with manpower, I'm now actually, you know, able to scale across my data sources, at least for the mapping. So then we get to the link the data. So and this is where the real power of the Tamr tool comes into play. So they use machine learning to figure out all the rules that you would previously do by hand. Now a human, he kind of breaks down when you have 20 or 10 probably interrelated functions that you need to think about to determine whether something is the same or not. But the computer, it doesn't have that problem. It can have 100, 1,000 different rules and nuances because it's all the same for him. And so making these models, making these functions, that's what machine learning is about. Now you do need to train it. You do need to tell it, you know, what is the same thing? What am I looking for? And so the way you do this, it's, you know, here's my friendly little robot again. The way you do this is, well, you do it by evaluating record pairs. This is really simple. So Tamr, again, it goes out and it profiles all of your data, and it'll give you a representative subset of record pairs. So it's kind of like market research. You don't want to just see all of interview only bald white guys of 50 years old. You want to have a nice spread across the population. Similarly here, you want to have a nice spread across your data set of pairs that you're going to compare. And just like for market research, there are heuristics that you can employ on top of your data set to make sure that the resulting subset, the resulting sampling of that is actually statistically relevant and is contributing the maximum amount of information to the model. And so this is again something Tamr takes care of in the back. You just say, give me some stuff to label. And what does that look like? Well, he comes up with like this, only in reality with more attributes. But he'll say, I've got a record which is Bob Smythe, and I've got one which is Bob Smith. Are they the same thing? So in this case, you say, yeah, it's the same guy. And then he'll come up with, well, I also have Alice Smith and Bob Smith. Are these the same thing? Well, no, they're not the same thing. And so that's all you have to do, really. So you just label all of these pairs. Well, not all of them, actually. You just label a few of these. And to just give you some numbers, from one demo that we did, we had about 4 million source records, which we eventually consolidated down into 1.5 million entities. And we had to label 1,000 pairs for it to work. So it's like when you compare those numbers, that's huge. I mean, labeling 1,000 pairs, it's boring work, but you do that in 2 hours. There's like 2 hours of yes, no, yes, no, yes, no. Oh, missed that one, no. So that's kind of, that was all it took. Now, obviously, there's some validation that you need to do, and you'll have to go back. So you won't do it in an afternoon, but still. So yeah, a business user could do this. There's really just 2 buttons on the UI. I hope we all work in IT, right? So, but actually, the reason this is on here, I don't want to very intelligent people in the business across all the industries, but in fact, that's actually the point why you want them to do it. I'm the IT guy, and I speak a few languages, and I can probably identify similar customers in Belgium and France and the UK and the Netherlands and Germany. But once I get to Russia, seriously, I don't know. Are these two the same? I can't even read the damn name. That doesn't work. I cannot do that job. And in fact, even the IT guy that was responsible for writing the scripts, now he's obviously profiled the data a lot. He knows a lot, so he can be one of those data experts that labels. But you don't just want one guy, you want multiple opinions. And very often you'll find that, for example, in my business, the guy who really knows the customer, that's the retailer. So in fact, I want to give this to my retailer network. And I want to send those pairs to my retailers to label. And ask them, is Bob and Alice, are they the same? And you say, yeah, no, they're not the same, but they're married and they have a dog. They know the customer up to that level. That is where your knowledge is. But, you can't have them write scripts. You can't have them, if the UI has 20 different fields on it, they'll sort of freak out. But they can't click 2 buttons. And they want to click 2 buttons. That's actually the main deal. They can click more, but they don't want to. But this they can do. And then the next thing is, we can now also, because it's very easy, to add information to the system, we can regularly train new pairs as I add new sources, as the profile of my existing sources evolves. I can keep my model up to date, because all it requires for any individual expert to do is label 5 or 10 more of these records, and boom, my model is back up to date. So every now and then, like once a week or something, these experts, they will get a mail and they'll label 5 of the records, and your unification model, it stays up to date. You get high quality results all the time. And that brings me to the final bit. So now I have my really nicely consolidated data set. So, and one of the things that we want to, like I mentioned before, want to stop doing is create new databases for customer data to live in. But it does bring a bit of of a problem with it. Because, well, I have my existing sources. I work for a very big enterprise, and these big sources, they don't go away. I'm not sure. I missed the census on who works for what, but if you work in any multinational enterprise, I'm pretty sure you have a database that's been around since 1965, and that's still in operation right now. So all of these existing sources, we will get rid of some of them, but trying to get rid of all of them, it's not going to happen. So we need to keep on running my unification model. I will always need to keep on deduplicating all of my customers. But if I create my new consolidated set, well, at some point you're going to want to do updates on that. And in fact, that's very relevant data for your deduplication that you're still doing. So you want to make that data available as an input to your mincing machine as well. That should be there. But if you would just do it naively and you pick this one and you make it an input, you're gonna, you get a feedback loop. It becomes a bit annoying because, well, each change of one of your records actually triggers a deduplication run, which might change how your records are clustered and merged, which will cause a change in your consolidated data set, which causes a change on the input, which triggers dedupe, so in fact it never ends. And the system will start oscillating, for lack of a better word, and you really don't know where it ends up. If you're lucky, you will end up in a consistent state, but most likely not. So you can't just naively pick your resulting set and allow updates on it and make that an input. So we had to do a little trick, which I'm going to go. So a second thing is, well, we do have this requirement for multiple views. And so what we're doing is we're not merging the records at all when we make our consolidated set. In fact, we keep all of the data. So each of our customer records is actually an array of all of the customer records that we have, along with some meta information around it, such as where did it come from, when was it last changed. And then actually when you walk up to the system, you tell it, well, I want to get this customer in the CRM view, or I want to get this customer in the all values view. And depending on which view you ask, I will trigger a function over. So for my CRM view, you could output Bob Smith. All values will give you arrays of all the values. The finance view will be Robert Smythe, because that's his actual legal name. And so all these views are actually functions that run across this array of source records that I have, which do things like give me the most common value, and if that doesn't work, give me the value from this system, and if that doesn't work, give me the latest value for each of the attributes. And when you query it, I'm actually running all those functions across it. Now, the reason that works is because, well, any individual cluster is only a few hundred records, so I can do that fast enough and give you on demand the view that you need, because I'm keeping all the data. So this is so the second bit is, well, what if we get new information in? Well, we actually just save that as a new record. So we save an update event just as a new record on this customer, along with who told us that there was new information and a timestamp. So we're saving everything as immutable events. So then my customer starts to look like this internally in my system. So it sort of looks like I've got a Bob Smythe at T0 and it came from the sales system. I've got Robert Smith at T-1, it came from the portal. I've got Bob Smith again at T-3, I think, T-2, and it also came from the portal. So this is actually a name update in the portal. I've got Robert Smythe at T-10 from the finance system. And so, in fact, my customer now becomes a group by record ID, and the record ID is given to me by Tamr, because that's the cluster ID that Ted showed you. That's my record ID. And if you do that group by, you get this view, and you get this representation, and that's what you can use to consolidate. But to make it available to the Tamr application, I'm actually doing some sort of a pivot on this. So I create a pseudo source by each of these providences, by each of these origins. And I'm putting all of these events into those sources. And then they start looking like this. I have a pseudo source called sales, portal, and finance. These are not actual databases. They're really just the origins of systems that gave me updates on my system. But I'm making them available as sources to Tamr. And each of these are actually the event IDs. They're not actual records, they're events. And so I've done a group by provenance here. And what this gives us is, well, if now Tamr decides to reshuffle some of these events because it finds that, well, these two guys are the same thing and I'm going to put them together, that actually doesn't trigger a change on my inputs because all of my events are still the same. They still have the same origin. It's just that one attribute, the record ID, changes and my group by in the other view will change, but the inputs to Tamr don't change. And I break my feedback. And this way, I can get new information from on my consolidated data set, and I can just write it to it, and then asynchronously make it available to my deduping machine, and run a dedupe on it. And should things change, and they probably won't, but should they change, I just move the events to a different cluster, and that's it. So that's this bit. So the machine learning model will group these events into clusters. Right on. So that's my final slide, or so, almost. So the thing we've built is it can integrate our legacy sources, which are going to be for as long as I live, probably. It scales well as a function of sources because the machine learning takes care of all of the hard bits, the annoying bits of linking them together. In fact, the workload to integrate a new system onto this is lower than it was for the previous system. I get a very good scaling characteristic. It obtains the knowledge where it resides. So I can give this to business users, I can give this to my retailers, and I can get their knowledge on the domain, on the customers, and have them train the model. It supports these multiple views because we have so many of these customer databases. I need these multiple views, and it allows me to do that. The next thing is I can stop creating new customer databases. Hooray! And then the final thing is it allows me to create new processes on top of this data, so that can drive my CRM, but that can also enrich this data without the system blowing up. And that was very important for us. And that was it. So, questions?
You group your original data in people that are most probably, facts about probably the same customer. Mm-hmm. Your Robert Smith and Bob Smythe, and that's a simple grouping of these are in one cluster. Yeah. And it's 100% between these two and 0% with the rest. But what if it's there's a 95% chance or 85% chance it's the same one as Bob Smythe is the same as Robert Smith, but there's also a 60% chance it's the same as Robert Smythe somewhere else. You get into more...
There are cases you cannot solve, period. This will not reach 100% accuracy. So, in fact, you cannot do that. So that's when I go and sell this internally, that's the number one thing I say. If you expect this to give perfect results, we should stop now. It won't. And the traditional approach also won't. Now what you're describing is actually the clustering problem. That's not, mathematically, that's not a simple problem. Like you said, well, if I have, there's a whiteboard. If I have a lot of dots, let's say it's two-dimensional, because this is actually n-dimensional, with n being your attributes, so it becomes a bit more complex. But let's say it's two-dimensional. I have a few dots. Well, the ones I'll just draw it. It's probably the easiest thing. So obviously, one doesn't work. So I've got a few points. So when you eyeball this, you'll say, well, this is probably a cluster. This is probably a cluster. But where did these go? Right? So That's a clustering algorithm. And so what you'll find is that there's lots of really nice literature around how this goes, but you will always have a few where it doesn't work. In this case, Tamr will just make a decision. There are systems out there, by the way, that work with a double threshold, where it says, well, if it's below this, they're definitely different. If it's above some other number, it's definitely the same. And the ones in the middle will go out and I'll ask a human. Tamr doesn't work that way. So it will make a decision for you. Now, if you find out that a certain category of records are continuously mislabeled, you can go in and train it extra. But it's a design decision these guys made. And so actually for the clustering, I'm also relying on them implementing the right math. But there's definitely algorithms that do this. And it's also nice that you can rely on people who studied this at university for a living for quite some time, rather than having some guy who, did his last algorithmic course in the first year of university and then did programming, try and build this on his own. So that's also one of the reasons why we went out and bought Tamr. Because a lot of these machine learning algorithms, they're available. You can find them in papers. You could implement them yourselves if you want to. And you can implement a few of these and you can weigh them together. But do you really want to do that? Or do you want to buy that expertise outside? For your case, you might want to do that. We decided that we'd rather source that in. So what I'm saying is I'm relying on the tool, and it will always come with a decision, but it might be wrong, and you should validate. And if you find that it's not good enough, you should go in and train more. But you must accept false positives and false negatives.
I was aiming at something a bit different. You said that this is like it's 100% or 0%. Ones in the left cluster are 100% linked and 0% with the rest of the. You might have more information if you say there's a small distance with those and a bigger distance with this one. And
but that's the design. That's actually what I said. It's a design decision that they made, saying, well, we won't expose that uncertainty internally. Actually, this thing, there's no 100%. It's never 100% the same. It's always with some likelihood. It's just if the likelihood makes the threshold, I merge them. If it doesn't, I don't. But it doesn't expose this to you. So it's binary from the user perspective, but internally there is this uncertainty. But it was their decision not to expose it. So you don't have to care about it, and I have to trust it, basically.
Well, did you get any legal issues by combining this data and enriching it, basically?
So yeah, sharing customer data around is tricky. So yeah, our legal department had a field day when we started this. But actually, so far we haven't run into any issues where people complain, "Oh, you've merged me with the wrong guy." No. No.
In a sort of data strategy context, I mean, you're talking about trying to get this mess in order, really.
Yeah.
To plumb it, to get some stuff out of it. But isn't the end goal, like, let's say, a couple of years down the road, to get rid of a lot of these data sources, or to clean up, the things that are really crappy legacy that you shouldn't be dealing with in the first place, or?
Yes. But realistically speaking, it's going to happen for some. It's not going to happen for all of them. Some of these systems, they stick around. And so for me, when I put on my architecting cap, I'd like to get rid of some of these. I'd like to get rid of all of them, but I have to accept that I cannot. So I have to design for the fact that there will be multiple ones. Especially given, if you think back about my first slides, is we don't own all of these companies.
Yeah.
So the ones we own, we have a bit of a, we're trying the carrot approach, but we have a bit of a stick to hit them with if it doesn't go the right way.
Yeah.
But the ones we don't own, there's just the carrot.
Yeah, you can't do much.
Right.
Going further on that comment, you work with fully owned companies and more distant companies.
Mhm.
How do you convince the other ones? You say the carrot, but if I were a distributor, I wouldn't be that keen on actually sharing my customers' data, even if it's with a good company.
No, and they're not. They're not. This is a very hard, basically political problem that we need to solve. So, in fact, so I didn't highlight this actually. So I focused on the plumbing, on the underlying foundational work that we had to do to consolidate the data. I took a bit of a high-level architectural view. So, but one of what actual sales pitch is that we have sources of customer data as well. So, like I mentioned, we have a common platform for the website, so we get lead information in, we get click streams in from the website, we have the warranty information also comes in via central system. We have some sources that these distributors want. Now they have access to the individual sources, that's not the problem, but we can link the customers that live in these sources with their customers, and therefore enrich their view on the customers with data that we have. And that's the carrot. So when they get on board of this program, we will link up the customer portal, which is also a centralized development. We will link up the lead capturing of the website. We will link up the warranty system with this system. So those will be sources that are already there, that will be linked, and that will greatly enrich the data that they get out of this and that they want to use in their business processes. And that's a very big incentive. The second one is basically that, especially for the bigger ones, for example, TGB's been so that's Great Britain. They've been around for a very long time, and they have a lot of sources themselves that have customer data. And so there the sales pitch is, well, we have this awesome piece of technology that can help you, but the condition is that it goes onto our platform. So, we're there to help them, but obviously, so these are ways that we try to get them to agree on sharing the data, on basically on trusting us with it. And the main point is that we try to offer some out-of-the-box integrations that bring value for them right off the bat. And so we're very much focusing on that when we shop it around.
We have time for one more question, then we'll have to round up.
Sorry.
Don't you have fight at the start of every project, like business analysts? Now, for this project, we're going to take the CRM customers. No. For this project, we have to take the finance customers. Or better take another department's customer version of the truth.
Yeah.
Isn't it like a discussion at the start of every project from now on?
Yes. It's the problem is that just having one won't cut it. So, and by having some of these views, I'm making it their problem rather than my problem. Because otherwise, seriously, otherwise they'll just come in and they say, well, this doesn't work for us. We don't want to see that name. This won't work for us. You can go play somewhere else. So, but yes, that is definitely, you fix some problems, you create some problems. So, in 2 years' time, I'll be explaining that one. Cool.
Well, thank you very much. Thank you. Thank also Peter, who disappeared, but for organizing this event. Like always, if you have a good topic that you want to share with us, we'll be happy to host you. We'll be happy to support you and to distribute that information to all our members. So thank you once again, Wouter, for this excellent presentation. Thank you to Mr. Janssen for the presentation. To the person from Tamr also. And to Peter, it's not back yet. So see you next time. See you next week on Thursday night at the VUB. Thank you. Bye.